When source is at rest, the wavelength are not going to change. Okay, later I'll stress it in detail. Okay, if the source and observer both are moving, then sir, how you manage things? Both source and observer are in motion. So this is the source. Let me put all the cases here only. Source. This will be an observer or detector. Both are same. First case, source and observer are moving towards each other. Next, they are moving away from each other. Next, source follows observer. Observer follows the source. So the source will generate signal at frequency f. And it will be received at f dash. So how to calculate the apparent frequency? And what is V? V is called as what are V is? Speed of source. What is V naught? Speed of observer. And what is V? Speed of sound. Okay, this one. Okay, first case. 1, 2, 3, 4. Now, first case, what is the apparent frequency? Both are moving, what to do? Okay, then if an observer moves towards source, what is the condition? V plus V naught we should write. Look at this. If observer moves towards the source, in the numerator, what happens? It has become V plus V naught, no? You need not to again think in this way. Just take help of this conclusion. And if the observer moves away, in the numerator, it was V minus V naught. So now you can see this. This will be, so what is F1? F1 will be observer moving towards source. So V plus V naught F. Source approaches observer. Where in the denominator, it was V minus Vs. Got the idea? Denominator it was V minus Vs. So this will be, this is the apparent frequency in the first case. F is the actual frequency. So what is F? We'll define F also. What is F? This is the apparent frequency in the first case. Second case, F2. Or select a F1, I'll write it. F2. So can you write anything? So V minus V naught. Observer moving away from source. Source moving away means in the numerator. You need not to again, no sir, I will think in the way you have taught it. Okay, you can take it, but in exams what happen? You don't get a time to derive directly the conditions, what the basic conditions, what I discussed. Now from that what happen? You should get a formula and you have to work out. What are F1, F2? Apparent frequencies. Apparent frequency in first case. Apparent frequency so what is now F3? Shall we write V minus V naught F by third case. So now this will be, what is F4? F4 will be V plus V naught. source moving away, V plus Vs. Okay, got the idea, no? So like this, what will happen? We can calculate the apparent frequencies. So very plenty of numericals are available, but that's the basic idea, that everything just revolves around this condition. Any doubt? If you have, you can clarify. Any doubt? We can also discuss wavelength. Okay, this now we'll find very difficult. Tomorrow's class, I'll show you even how to calculate wavelength. First, you get adjusted yourself to how to get the apparent frequency. Strictly, what is Vs and Vo? They are the velocities measured along the line joining source and detector. What happens, like if a source and observer, the velocities are not in same direction, not along line joining. So we'll take one case here only. So it will